A very warm welcome to you from Z Training Academy. My name is Dr. Zulfikar Kisam. Thank you for joining once again. Today we will cover network analysis using Wireshark. So the idea here is to be able to capture, analyze, and troubleshoot network traffic. So there'll be a series of lectures I'll do. This is the first one in this series. So let's try and look at that, right? But before we go forward to talk about Wireshark, let's try and understand the most common network connectivity and performance issues we face. So there are two slides on this. These are the first 5 items, and there'll be 5 more items on the next slide. So as you can understand, network issues can impact users, applications, and business operations, right? And it is important to identify the root cause quickly, right? This is the key to minimize downtime and to ensure optimal performance, right? So these are the 5 things here, as I mentioned, and we have 5 more on the next slide. One of the things you'll come across is no connectivity at all. So you cannot reach any website, server, or any network resource. So things to look for in this particular case is make sure, of course, the basic things that you may have come across, right? Cable unplugged, NIC disabled, switch router is down. That is a good possibility here. Or there's an IP configuration issue. Whenever there's a chance, of course, you want to use DHCP, which is Dynamic Host Control Protocol, to basically give IPs to all the people in the enterprise. You want to try to stay away from manually having to configure the IP address. Now, the second one is DNS resolution failures. This is a little bit more common. You can't resolve domain names, but IP addresses may work. So this may be because your DNS server is either unreachable or not configured properly. So incorrect DNS settings, for example, if the wrong server is configured, DNS record issues, may want to see what's going on, or maybe there's some DNS that is already cached in your computer that is no longer valid. That could be possible. Or firewall blocking DNS, right? So DNS issues can be common. So we need to understand that. And this is one of the things that we will look at in the traffic capture, what you're going to be looking at in terms of DNS in Wireshark. So we'll be looking at that at the end, by the end of this lecture. Yeah. Then there is the high latency, slow response times, lag in applications, high ping times. For example, you ping something, it takes a long time for it to reply, right? So this could be due to network congestion, long physical distances, overloaded devices, insufficient routing. So like long distance physical distances, for example, I work in Vancouver here. I've been lucky enough to work for multinational companies who have, their sites in England, Singapore, Japan, and so forth. And yes, the long physical distances will slow things down, but you have to understand the reasoning or how far will that be acceptable. For example, I live in Vancouver. If I ping a machine that is, for example, in New York, right? So Vancouver is on the west side of Canada. New York is on the east side of United States. To span that much distance, which is about 5,000 kilometers, the ping time should be 60 milliseconds, 70 milliseconds. It's not that large. You should still be able to function fairly well, even if you are connecting from Vancouver to New York or vice versa, even though the distance is fairly large, 5,000 kilometers. You should still be able to ping in a reasonable amount of time, which is about 60, 70 milliseconds. If I am going same thing from Vancouver to Toronto, for example, which is also around about that kind of distance, it should be about 60 milliseconds. If I'm going to England, on the other hand, from Vancouver to England is like a 10-hour flight, then I'm considering my ping times to be in the 100 millisecond range. On the other hand, if I'm in Vancouver and trying to ping a machine that is in Singapore, which is kind of half a world away, then you're looking about 200 millisecond ping times. And then if you're going to Japan, then that'll be 300 milliseconds. But if you're getting slowdowns more than that, then there's the issue with the network, right? So just have some form of context behind how much the ping time should be based on the location. Then there is the possibility of packet loss here. Number 4 is packet loss here. If you have intermittent connectivity, choppy voice or video transmissions, right? This can happen due to, of course, network congestion. There's too much traffic on the network. Faulty cables, hardware, could be wireless interference, could be overloaded links, but also could be due to misconfiguration. I went to a place once, and what used to happen over there is there was some misconfiguration between a couple of switches, which caused the whole system to go down on a daily basis, really, for 2 years. It was going down exactly at the same time, exactly the same hour, every day for 2 years. They could figure it out. And when I went there as a consultant, I said, "What's going on? How come I'm seeing this issue, which is kind of rather strange?" And then we looked at it. There was misconfiguration on the switch side. The switches on the two sides need to be configured properly when they're interconnected, because if there's misconfiguration, in this particular case, it was about LACP, which is known as Link Aggregation Control Protocol in Cisco. So you need to configure both sides to be in the same way. So if you say auto configure the LACP settings, then it should be auto on both sides. If it is fixed, it should be fixed on both sides. If one was, in this particular case, the one was auto and one was fixed, and as a result, they would always renegotiate this on a 24-hour basis, and the system would go down for a bit. Everybody will lose connectivity, and then it'll come back up, finally figure itself out after a couple of minutes, and then everything will be fine for the next 24 hours. So it's very important, these small things. It may seem small, but it can have usually very, very big impact. So when you're configuring a switch, when you're configuring a router, you want to make sure everything is configured as per best practice, right? The fifth item here is low throughput, right? So slow download, slow uploads, poor application performance. So that could be possibly bandwidth saturation. Your bandwidth is being saturated for some reason. There is quality of service misconfiguration, or there could be background traffic or server limitations. So what you want to do here is to make sure you're proactively monitoring your network and rapidly troubleshooting to create a reliable network. And this is where a Wireshark comes into play. Now, of course, you can use basic things like ping and trace route and speed test to make sure everything is good on a regular basis. What Wireshark will give you a great insight what's going on. Okay. Now let's go to the next slide here. So Wi-Fi issues, yeah, weak signal, frequent disconnects, slow or unstable connections. So this could be due to signal interference. Make sure your signal is good. I have a wireless course. It will take a long time to get to that, unfortunately, because I'm still very, very busy trying to get to different the data communications course going, but eventually we'll get to the wireless course. But in signal interference, as the signal strength can make a lot of difference, right? Channel congestion, AP misconfigurations, which is the access point misconfiguration, can also cause a problem. So you want to look into those issues. If you have internet, or I would say intermittent connectivity issues, connection drops randomly or works unpredictably, that could be due to flaky cables and ports. So this is not to be taken lightly. I remember going to one place and the connection was really, really flaky. And then we realized that, hey, when you go up where the cables were running, it was being affected by interference with other electrical wiring that was there in place. So we had to buy better wiring with better shielding to make sure that we fix this issue, right? Especially if you're going very, very fast speeds like gigabit Ethernet speeds. If there is any interference whatsoever, this will really cause a problem, right? If there are any power issues that you may possibly have, any driver firmware bugs, always look for them. You're going to make sure your systems are updated with firmware. And if there is the internet service provider instability, right, that could also cause issues. Then there is firewall ACL blocking, cannot access specific ports or services or application. It could be incorrect firewall rules being set up. Could be access control list misconfiguration, right? Because you can specify ACLs on the switches and routers, but you need to make sure that they're correctly configured, obviously, otherwise it will block traffic, right? Any block ports on the firewall and any security policies that you may have applied. Then you may come across server issues as well, where the server is unreachable or times out, or slow application response. So server down or overloaded could also cause an issue of course, application failure, resource exhaustion. So either memory or CPU is pinned at a certain level and it's starting to cause problems or slowdowns, or it's lacking maintenance updates. It's very important that you always maintain your software, your operating system, your applications to the latest updates to make sure they're secure as well as reliable, right? Then you may come across routing problems, which also can be fairly common in certain places, right? Until everything is stabilizes initially, especially when it's a new environment, you may get some routing problems until everything is fixed. Traffic takes longer. It may come time to time as well due to some issues, right? So traffic takes long or incorrect paths or is unreachable. So you may want to make sure there's no routing loops in place whereby the traffic just go round in circles, right? Misconfigured routes, uh, or BGP or SPF issues, right? And ISP path changes. So internet service provider path changes. So something changes on the ISP side, you need to be aware of that. And if there's any recommendations they make, you want to be sure, or you want to make sure that you are keeping ahead of that. All right, so now we'll go to the next slide here. So what you want to do is to make sure that your networks are reliable as possible. So as I mentioned before, proactively monitoring your network, right? Rapid troubleshooting will make sure that your networks are reliable. And that's where Wireshark comes into play. So always monitor your network continuously, troubleshoot quickly, keep your network running at its best. Now, of course, it's not always possible to run Wireshark all the day, but it's time to time you may want to have a look at it on a regular basis, on a whether it's a daily basis or a few times a week. Have a look at what your kind of network traffic looks like, and especially you want to use Wireshark if there's an issue in the network for sure to analyze what's going on in the network. So what is Wireshark? So it's an open source packet analyzer, basically, right, for deep inspection of network protocols. So the good thing, it's free. You can download this, install it on your machine, and it will allow you to capture live network traffic in real time from network interfaces for detailed analysis. This is what a Wireshark capture will look like, right? So it'll give you the number here, the time, right? And the source of that packet, the destination of that packet, the protocol that's being used, the length of that packet, and any info related with that. When you click on a certain item, it will open up much more information for that specific packet, right? So for example, if you click on this and you highlight this packet in here, it'll show you, for example, excuse me, it'll show you the frame, which is layer 2 of the OSI layer is the frame. It'll tell you the source and the Ethernet 2 information, which is the source MAC address and the destination MAC address. It'll tell you the source IP address and the destination IP address. It'll tell you layer 4 information. So here, Ethernet is layer 2, frame is once again layer 2 information from the OSI model. Then IP is layer 3 of the OSI model, which is IP addresses. And transport layer is where this comes into play, the TCP. If it's a TCP, it will tell you the source port and the destination port. And then it'll give you layer 5 and layer 6 information, which in this particular case, it's using TLS, which is transport layer security. So it'll give you good insight of what's going on in your network. So this is used for troubleshooting, security analysis, and protocol learning. It will help you to identify issues, detect threats, and understand how protocols work. It supports hundreds of protocols, right? So a wide variety you'll see in here. You see over here from this here, it's looking at DNS, for example. It's looking at ARP, Address Resolution Protocol. DNS is Domain Name System. Then you will see TLS, for example, right? Transport Layer Security. That is being used in this case, right? So all sorts of protocols are all supported in here. It's a quite phenomenal product. So when you look at the network frame breakdown that we saw in the previous slide, you saw information about layer 2, which is the source MAC address and the destination MAC address. Right? Then you will see layer 3 information as we saw from the previous screenshot, source IP address and the destination IP address. Then you saw layer 4 information, the transport layer, which is the source port and the destination port. Then you saw layer 5 information and 5 and 6, which is the TLS, and it will tell you which version of TLS you're using. In this day and age, to make sure that your networks are secure, you want to use TLS 1.2 and 1.3. You definitely want to disable SSL version 3, for example, and lower. You want to disable TLS 1.0 and 1.1 as well. Only 1.2 and 1.3 are considered as being secure. Then you saw the HTTPS information. You'll see that as well, and which actually carries the application data, which is layer 7. Okay, so this frame that you saw previously was a secure HTTPS communication from this IP address to this IP address. Okay, and you can see that all the 7 layers identify here for your information, and you can see each piece or each layer information is depicted within Wireshark. So how does the packet capture actually work? So the network interface receives the frame, right? So your network card will receive the raw data frames from the wire. It will capture the packets in what is called promiscuous mode. I'll explain what that is in just a moment. Okay. And packets are decoded into readable protocols, as you can see over here, right? And the analyst, which is going to be you, and I, we're going to inspect that information and figure out what's going on. So what is promiscuous mode? Now, in a normal mode, which is what your NIC is normally is in this mode, not promiscuous, okay, not promiscuous by general or by default, meaning to say it will only listen to traffic, network traffic, that is destined for this machine. So it will only look at the traffic that is destined for the MAC address which belongs to your machine. So let's say your MAC address is BBBBB here all the way. Then it will only listen to that traffic that is destined for this machine, MAC B. Okay, it will ignore any traffic it sees which is for MAC C or MAC A. If it's in promiscuous mode, basically what it will do is that it will listen for any traffic that it sees for even different MAC addresses. Now, mind you, you have to understand that switches in general will not send traffic to any port unless it is destined for that port. So just keep that in mind when you're doing this troubleshooting, right? If this is a hub, of course, it'll see all the traffic. But once again, you'll only see your traffic generally. But in promiscuous mode, it should be able to see all the traffic. Okay, so how does this work? So what you want to do here is to figure out, I have a Mac, for example, right? So I want to figure out my IP address, my router address as well here. So this is my local IP address here. This is my router address. And I start the packet capture. So now what I'm going to do here in Wireshark is I'm going to say, hey, there's a lot of information being captured by Wireshark. I don't want to see everything in there. Now, if this is a small home network, you won't see that much traffic, so you may be okay. But if this is a large network, you'd probably want to narrow in what you're looking at. So here you're going to specify, hey, I'm going to be looking at only the traffic that is coming to my machine or going from my machine. So what I can do is I can look at the packet capture and then specify IP.address, ADDR, is equal to my own IP address. Once I do that, that means it basically filters all the traffic to look or analyze only the traffic that is being sent from or to my machine. Now you can see here, for example, what I did was I started this packet capture and said, hey, I want to go to google.ca. Okay, so this is a standard. You can see here the protocol being used here is DNS. So I started I started the network capture. I started my browser. Okay, after that, excuse me, and I tried to go to www.google.ca. When I did that, basically there's a standard query, a DNS query that is being sent to say, hey, who is google.ca? What is the IP address of google.ca? Now you can see one query that is 4 A's, and there is one query which is single A. Single A is a TCP IP version 4 query, and one with the 4 A's is a TCP version 6 query. So it does both queries in TCP version 6 with the 4 A's or TCP version 4 with the 1 A's. And when you look at there, so you can see in here, the DNS uses port 53. Okay, it uses UDP, right? User Datagram Protocol. It doesn't use TCP. DNS uses UDP, User Datagram Protocol, UDP. Okay, and the destination port will be 53. So what does that look like? So if you want to specifically identify only DNS traffic, what I've done here is not only have I specified my IP address, but I've also specified that end DNS. So it has to be my own IP address, and it has to be only DNS traffic, because that's what I am trying to focus my attention to. So I can say that I need to specify I'm looking only for protocol DNS. And you can do this for any protocol. This is an example of DNS. If you're looking for ARP, then you can put in ARP and so on and so forth. So now it's showing me only those packets that have been captured regarding DNS. Now, if I go in here and look at one of the DNS packets, it shows me in here when I was trying to get to google.ca, type 4A's, which is version 6 of TCP. I am getting this address. This is a TCP version 6 address for google.ca. Okay, so you can see this 2607. In one of the lectures, I will cover TCP version 4 and version 6 as well in the data communications and network course. But this is a version 6 address. This long address that you see that starts normally with 2000 is a version 6 TCP IP address. So nowadays, most of the large providers, like big companies, Apple, Google, you name it, they'll have a version 6 IP address and a version 4 IP address. So you can see the response google.ca. This is the version 6 of the IP address. Once you open this up, you get a lot more information in there. At the same time, you'll see a reply coming in from version 4 of the IP address, which happens to be 172.217.14.227. If you open this packet, you'll see here, this is type A, which is version 4 of the IP address we saw previously, 4A's, which was version 6 of the IP address. So this is version 4 of the IP address, which is as such. Okay, so you can see we're getting very important and kind of interesting information about DNS, and you can do this for any protocol. We'll talk about other protocols some other time, but just I wanted to give you a kind of gist of what that looks like. In certain cases, what you may have is what is called a canonical name. So when you type in a certain name, the response will not be an IP address. It will be another name of a different form, and that's called a canonical name. For example, when you try to go to Amazon, it may come up, the result may not be an IP address necessarily. There'll be a scene name entry. You can see the scene names in here. This will be another name for trying to get to where you are trying to get to, right? So this is an example of Amazon.com in which it's not giving you an IP address, but it's trying to get you or redirect you to another site. Okay. Same thing here. This is another Amazon entry over here. You can see there is canonical name in this particular case. It tries to take you here. And then finally, it finds one of them, CMedia, Amazon.com, to have this as the IP version 6 of the address, where you see 4A's. That's version 6 of the IP address. And once again, canonical name is another name that is trying to move you into. So you can see here canonical name in here. The C name is the canonical name. All right, well, thank you so much for watching for today. I will cover more ground next time. Till then, take care, have a wonderful time, and God bless.